Welcome to this video on the topic of statistics. In this video, we'll be having a look at how we can go about representing continuous data in a graphical manner. Now, the graph that we're going to use to carry out this process is we're going to use a histogram. Now, a histogram is quite similar to a bar chart, however, there's a few minor differences. The first difference being in that a bar chart is used to represent discrete data, and a histogram is used to represent continuous data, which is what we're working on today. Now, if we go over and have a look at a few examples of histograms, by simply typing histogram into Google Images, it brings up a variety of different graphs that we have over here. But what you're going to find, the general trend is they look very similar to bar charts with a few minor differences. The first difference being in that what you'll find is most of these charts over here, or most of these graphs over here, they don't have gaps in between these columns, with exception to this one. Now, the reason for that is that histograms don't actually have gaps in between the columns here. So this histogram over here isn't actually a proper histogram. The second difference that you're going to find is the grouping of information. So rather, if we look at this one, rather than having, say, the 100 in between, and 100, or this column here is represented by 100, 200, and 300, the labeling or the numbers actually occur between the changes from the columns. So you've got 100 to 200, 200 to 300, and this is important in the construction of the histogram. Now, to understand the idea of these columns, what we need to look at is something called a class interval. Now, a class interval is simply a grouping category for continuous data. So by that notion, if we're looking at something, for example, like student heights, you've got 183, 167, 153, 158. For a class interval, you can't represent all of these numbers in individual columns like here. Rather, you're going to group them together. So in this case here, for histogram, for air passages, and frequency. So if you had a flight, for example, with 150 passengers on it, then it would get thrown in this class interval in here. So anywhere between 100 to 200 gets grouped together here. Anywhere between 200 to 300 gets grouped here. So if we were looking at student heights, for example, we might think it's useful to group between 140 to 150, 150 to 160, and 160 to 170. However, I'm getting a little bit ahead of ourselves here. Now, to be able to construct a histogram, the first thing we need to do is we need to organize our data into these class intervals. And after that, we use the table that we construct to then model a histogram in the image of something that we see over here. Now, the first thing I'm going to do to construct this histogram is I'm going to go by organizing this data into class intervals. So the way in which I'm going to do this, I'm going to draw up a table. And in this case, we're working with student heights. And then in this second column, we're going to have frequency. Now, the way in which I'm going to organize this, as I said earlier, I'm going to organize them in terms of 140 to 150, 150 to 160, and 160 to 170, and so on. So we go 140 to 150, then we go 150 to 160. Now, when we design these tables, it's always a good idea to rule everything up with a ruler. Reason being is it keeps it nice and neat. And if we have neat working out, then it makes our working out easier to understand by different people. So it's always a good idea to use a ruler for this stuff. Alright, now that I've got these organized, what I'm going to do is I'm going to count the amount of data points that I have in this data pool here, or this sample set, that fall in the category of 140 to 150. So what I'll do is I'll label this pink, and I'll go around and I'll label all the pink between 140 and 150. So we've got none in the first row, none in the second, none in the third, the fourth, but we've got one in the fifth row. So I'll put a frequency of 1. Next one across, we go 150 to 160. So in the first row we have 150, 158, 158 again, 155, and 158. So we have 1, 2, 3, 4, 5. So 5 items. So for our next class interval, we're going to look for 160 to 170. So we've got 167, 168, 162, 169, 168, 163, 166, and 164. So we've got 2, 4, 6, 8. Next one across, we're looking at 170 to 180. We have 175, 173, 171, 176, 179, and 179. So that's 2, 4, 6. And then we're looking at the final category now. So 180 to 190, we've got 183, 181, 183, 183, 185. So that's 1, 2, 3, 4, 5. So what we've been able to do is construct a class interval table. Now using this information that we've collated in the table over here, we're going to be able to construct a histogram. Now the way in which we do this is on our vertical axis, we're going to write down the frequency, so the amount of times we saw data points within these class intervals. And then on the horizontal axis, we're going to write in our class intervals. Now I should be able to fit it over here. However, it's always a good practice when you've got space to use. You want to draw your diagrams nice and big. The reason being is a nice big diagram is easier to understand, and that's the whole purpose of drawing these diagrams in statistics. So I'm going to use a ruler and I'm going to rule up some axes. Now what you're going to see is that I didn't really use space effectively on this diagram, so what I'm going to do is I'm going to rub it out and do it again. If time permits, you should never be too worried or too concerned about redrawing a diagram to make it clearer and easier to understand. Remember, the whole purpose of representing statistics in these graphical manners is to make the data easier to digest. Alright, that's looking okay. Now I'm going to mark each part, so 1, 8, and therefore we're able to represent the highest frequency that will occur in this histogram over here. Now the next step is I need to start drawing these bins or these class intervals. So the first class interval, so between 140 and 150, it's going to be 1. So I'm simply going to mark it out. Now the second one, 150 to 160, that's 5. Perfect. And what you can see is the outline of a nice tidy histogram. And therefore what you end up with here is simply a work of art. The only final thing that I forgot to put on is we should label this horizontal axis. So we should call this the student heights. And perhaps we should also give this a name, so student height information. So the key pieces of information for a histogram is that you'll notice that there are no gaps between the columns. The reason for the no gaps between the columns in a histogram is such that it shows that the data is continuous. So 170 flows straight into 180 and 180 flows into 190. So if you have gaps in here, then you haven't drawn your histogram correctly, as was mentioned over in this one here. This histogram is aesthetically different, but technically not a histogram because of these gaps. And the second key difference to take note of is that the naming of the columns themselves, it's in between the columns. So 140, 150 is in between this column here and this column here. So this has been a demonstration of, one, how we can go about changing this information over here and rearranging it into a class interval frequency table. And then using this class interval frequency table, we had a look at how we can construct a histogram.